You're listening to the SMD Radio Podcast. In today's episode, we are focused on the topic of NVH. Craig and Bob are joined by Signalysis President and CEO Neil Coleman to find out what NVH is and what Signalysis is doing to define and conquer NVH issues. Let's get into it. Neil, you are one of the busiest guys here at Signalysis, always solving problems, finding solutions, and dreaming up new ideas. While we have a moment, let's get to the bottom of today's topic. Let's start from the beginning by defining the acronym NVH. What does it stand for, and can you define it?
Good question, I guess. The NVH, noise, vibration, harshness. Noise is basically what you hear. It could be a rock concert. It could be, people babbling around in a restaurant or whatever, but it's normally measured in frequency and amplitude, and normally in sound pressure for pascals. Vibration is very much the same thing. It's measured in frequency and vibration amplitude, whether it's be Gs or meters per second squared. Acceleration, I guess, can also be velocity or in displacement as well, but we normally measure acceleration. And the harshness is how all of that kind of comes together in fields, whether it's something's very rough, like riding down a cobblestone road, which produces noise and vibration, or skiing across a glass lake, which is very quiet, except for maybe the boat pulling you.
Signalysis has a history with vibration testing that dates back to the Wernher von Braun rocket development era. Can you elaborate on this?
You'll have to go back and listen to the previous podcast with Bob, NASA Bob, and when he talks about his history of working on Polaris rockets and so forth after he graduated from college and got out of the Navy. But my background has been in structural dynamics, measuring the way things vibrate, the way resonant frequencies and the mode shapes that they produce, and so forth.
What industries are typically challenged by NVH issues?
Well, certainly there's always the automotive industry that has been working for years. One of the previous companies I worked for, Structural Dynamics Research Corporation, back in the 70s and 80s, we worked on actually redefining the way cars ride and vibrate by doing a combination of modal analysis and then bringing together FEM analysis, so you can actually tune the vehicle to be a much smoother ride. One of those was the Caprice Classic back in maybe '77, and that won Car of the Year as the best ride car as it came out. It's the first time really people started pulling all that information together, but we've used it at NASA. Certainly you need things for to run smooth when you're during liftoff, and but it goes all the way to dental drills and bone saws and even speech recognition applications.
You mentioned automotive. Can you talk about some of the areas where NVH is a real concern?
Well, from a quality standpoint, yeah, most of our work is in the area of sound quality or quality of the application, and how something rides, how something feels. Like in a sunroof, when you open the sunroof, if it squeaks, if somebody forgets to grease the rails, you'll hear a squeaking, and that's not going to be acceptable. And it's really just a customer satisfaction or avoiding complaints. But then other times, if you build a part with the wrong components, like maybe the wrong bearings or the wrong gears, it might appear to work and so forth, but it'll cause a lot of vibration and end up being a warranty item down the road because of the quality of the product that went into it.
So Neil, you mentioned a while ago about, let's look at the automotive industry, for example. Every product basically has got vibration associated with it. Is it true that maybe the effect of vibration is not necessarily is something that permeates through the system. It may be that in automotive, for example, it may be that a particular subsystem is vibrating. Its vibration is causing a problem in other areas. Is that typical?
That very much so. In fact, that's like on that Caprice Classic project we talked about. One of the big things was to identify and tune the suspension system to the so it avoids or filters out vibration due to the engine or road impacts. It gives it a softer ride and so forth. Whereas sometimes you get a much stiffer ride. There are some vehicles out there you'll ride and you go down the road and say, "Man, this is really rough." Well, maybe the suspension is too tough, too tight. They do that sometimes for performance in cornering and so forth. You don't want a really soft machine when you go around a corner, But so if it's a nice smooth ride, you want to tune out certain frequencies that are just automatically being generated.
So that kind of brings another point up. When we talked to Chris Cuss in a previous podcast, he mentioned that that's one area in particular that affects suppliers to the automotive industry, in that a buyer of say a Ford car or any brand name car, if the window rattles or if the air conditioning is making excessive noise, they're going to, in their mind, that's an issue with the car. They don't necessarily attribute that to the supplier. So in that regard, I assume manufacturers are really particular about their suppliers and the quality products that they receive from them.
100%. Like with Chris's situation, they make power seats, and we're working with them and other suppliers of all components, steering column, anything inside the vehicle these days. With the electric vehicles coming out, and it's so quiet, a little buzz or hum or a gear tick, just comes right out when you're sitting there riding along. And those really are all about on the showroom floor. You're trying to run the power steering or open the sunroof in the showroom floor. If that's not really quiet and purrs like a kitten, then you're going to have complaints, and people are going to get out of it and say, well, I didn't like that because my experience was wrong. That's kind of where our mission statement of delivering the ultimate solution experience. We want our engineers that are using our products and so forth to have a good experience of being able to screen out any of these issues and bring in and only shipping the parts that are nice and, like I say, purr.
In the industry, we often hear the term other objectionable noises. What does this mean, and isn't objectionable a subjective term?
I think you're exactly right. That's the real problem. There is, on almost all the specs we see, there's it cannot exceed so many sones, which is a loudness parameter, or so many dBA, which is a noise parameter. But then there's, or no other objectionable noises, and that can mean something that goes wah, 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 like a motor struggling type noise. It could be a ticking noise from a gearbox that, even though it's not above the decibel levels, you move it and it goes tick, 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 tick. You don't know where that's coming from, and it's just irritating to the consumer. And that's where we really shine with what we do. Our guys have the ability to take a combination of different types of measurements, whether it be current measurements, displacement, travel distance, travel velocity measurements, vibration, noise, and bring that all in to an algorithm that's going to allow you to put a limit on here. This is what acceptable. This is our score, if you will, for what that component is.
I assume that as products become more complex, that the possibilities for NVH issues is always present. Is this accurate?
That is, 100%. I'm finding these days there's so many different ways to use the sound and vibration testing methods that we use to identify defects, whether it be in a component that's moving, that's producing the sound, or maybe it's something that's just going to squeak and rattle. So, maybe you have two pieces of metal or a styrofoam. The worst case being when you're driving down the road and you have something in the leather vibrating back and forth and scratching and making a noise, and you don't know where that is. But a squeak and rattle is a big issue that we attack these days.
So Neil, I think that one of the areas that I typically tend to think about with regard to quality is scrap rates and rejected parts. But isn't it true that a lot of Signalysis customers are just testing to make sure that their products are falling within specifications of the customer?
Basically, I mean, the problem is, like Craig was making a minute ago, is that his comment on other objectionable noises, that's part of that determination of what a product is and what our scrap rate's going to be. So trying to learn from the customer, their customer, which is an OEM, of what's acceptable to their consumers, the drivers, that has to come into play with everything we do.
So how does Signalysis work with customers to eliminate NVH problems? Can you walk us through the process?
Yeah, so typically what will happen is we'll get a contact by the customer. Hey, let's say it's a new product, new vehicle being assembled and so forth. They'll come to us and say, hey, we've got this spec that for let's say a sunroof, and we're not allowed to be over a certain dB. We need 100% inspection on the product on the line, but there's all these other noises, and so we'll get involved and find out, okay, what is the size of the motor that's being used in the product? What are what RPM does it run at? What's the gear train associated with moving the sunroof back and forth? What kind of rails is it sitting on? What does the wind deflector look like, and how does that actuate when the sunroof opens? And then what are all the motions that we get involved? Do we have just the frequency, just the open glass, enclosed glass, lift glass, or is there also sometimes there's a power shade these days? And then there's all kinds of different functions within that. So we'll sit down and we'll go through the spec sheet, and we'll get some samples in here. We'll actually run those through. We'll make measurements at a lot of different locations. We'll probably put it in a sound booth and do some sound quality jury analysis with the supplier. And from that, we can start formulating metrics and designing a complete test system from ground up on functioning these parts. The good news is we've done so much of this over the last 35 years that, we go into it knowing a bunch of the answers already of what will work. I mean, even though there's a lot of new technology coming out in motors and a lot of new technology coming out with electric vehicles, things still work pretty much the same, and the science and physics behind sound and vibration really isn't changing a whole bunch. It's just how we apply the algorithms and the analysis.
Is it safe to say that sometimes you find that you already know ahead of time before even running tests, so that you kind of know, I kind of know what's going on here, or I know what the problem is already?
That is correct. A lot of times we'll get drawings initially, maybe not for the product design itself, but how it's going to be mounted in the vehicle. We try and get boundary conditions for how the product is mounted on the test line, and we say that's not going to work. A lot of people want to bolt test cells down to the floor directly, and that just doesn't fly with something as sensitive as our measurement system. Otherwise, there may be a stamping press next door to the test station, and we'll see all of that if they bolt it straight to the floor, whereas we can vibration isolate it using mounts on the system, and we decouple the station from everything in the plant. So it's kind of like floating in air.
Signalysis develops test systems to detect NVH quality issues. Can you talk about the software that drives these systems?
Yeah, the software itself is our CQC software, and it's designed to cover the whole scope of various applications. We've used it on dental drills. We've used it to measure bone density and risk of fracture. We have actually a patent taking it into the medical world. We across the board, the software is designed to interface well with all the different various PLCs that are on the production line, as well as interface to several different analyzers. One of the new analyzers we're working with these days is by a company, MeCalc, and that's giving us the a really big opportunity to expand into high channel count type applications.
Now, you say you guys have, I know that a lot of times you might have to create a crack or something in whatever you're studying. When it comes to the medical stuff, have you had to break any bones to test that out?
No, we haven't. I guess we went out and bought some buffalo bones to play with on that. But, it's science is, in my world, science has been so much fun. I mean, we actually, when we first started getting into this, back in the late or early 90s, I guess, we were doing roller coaster testing and to see how your body vibrates and whether the requirements, believe it or not, back in the early days, roller coasters were judged based on how the data that they had measured off fighter pilots and astronauts. And that didn't quite apply to the kids. Yeah, it didn't quite apply to the kids and women that were out trying to have a good day and getting shook the heck out of them, So, but that's probably a story for another podcast, the whole roller coaster days. But yeah, the measuring that and understanding, how vibration plays a role in your entire life is kind of cool. Everything vibrates, and everything you can measure it one way or another.
Well, that was the next thing I was going to say. Is there any unusual or interesting NVH projects in which you were involved in?
Yeah. So yeah, I guess that if you from that standpoint on the roller coaster, that's true. But I think the bone risk of fracture is kind of one of the coolest. During our early test days of proving a concept, we were able to test, people around the building and so forth, and your moms and dads and anybody that wanted to come in and let us take a whack at their leg.
I was assuming you gave them some insurance. So.
Well, it's a very light tap. It's no different than a reflex test, really. But what it is we're making the measurement, and then we're measuring how the bone vibrates. And just like your automobile and the space shuttle or anything else, your bones are going to vibrate in a known pattern, that's just going to change in frequency and damping. And surprisingly, we were testing my mom, and surprisingly, my mom would let us test her, but but at the same time, we were testing. So we would run a test, and we're getting all this data. And then one day, she came back in for a retest after we had changed some things in the software, and her numbers were completely wrong. So we're scratching our head and saying, what the heck happened with this data? So we started complaining to the software guys, hey, you guys broke something. And then maybe a day or two later, I was sitting around talking to Mom and said, man, sorry, you're going to have to come back and get retested. And she goes, why? And we said, the day. And she goes, well, I went in and got an osteoporosis shot the day before you tested me the last time. She had forgotten to tell us. But the cool thing is that we were able to find out that the system is so sensitive, we can identify how well drugs are working on the osteoporosis. And one little other highlight to that is we had one other patient that we were testing that was kind of off the mark. We said, well, that's an anomaly. That can't be. The kid's, 33 years old. We thought we were testing a good bone, but only to find out that 5 years later, he had already been developing a liver issue that was causing osteoporosis in him at such a young age. And so that's another exciting thing that, we're able to detect that, be that sensitive to detect some of that. It's a huge, and there is no x-ray involved with determining.
Well, my back's been bothering me lately. Can you guys give me a diagnosis? Or?
Yeah, I got a little golf club over here. We can do a slight little tap on you there, Craig.
All right. I think I can handle
hook you up.
All right. Well, I think that's all the questions I had, but maybe Bob might have something.
if you could take 1 minute and elaborate on you mentioned the process when you work with customers. How do you determine the threshold for what is a good number for maybe an uncomfortable seat or an excessive noise or vibration? Is that strictly is that an industry standard, or is that something that you would identify with the customer?
Normally, it's all identified with the customer. There are some standards that people work with, as far as, certainly there's a lot of OSHA standards for noise, but you would never think about the OSHA. But when it comes down to like bus drivers and so forth that are in the vehicle, there's some whole body vibration type metrics that are on there for, how long you can be, sit in a vehicle and get vibrated at a certain level before you get fatigued and so forth. And it's kind of something we did on the roller coaster testing too, is how often can you continue to ride a roller coaster and without it affecting your body.
I remember you riding a roller coaster over and over and over. Did you notice any effects from riding on that so many times?
Yeah, that's a fun story too. We can you can add that later if you want.
Another podcast.
Another podcast probably. But yeah, I'm getting off the roller coaster after riding it for 45 minutes. I got off and the guys I was working with said, "Neil, what have you been drinking up there, man? You're stumbling around, you're slurring all your words and so forth, and it looks like you're inebriated." And I remember, we were all laughing and stuff, and I went back and started looking at the data, and it sure turns out your brain has a resonant frequency somewhere between, I think it's 12 and 15 hertz or something like that, and right there in the medical documentation, if you're subjected to that vibration for a period of time, you'll appear to be inebriated. And I remember what they told me, so I started cramming through the data, and sure enough, on this particular coaster, they had like a pogo mode, like a slinky kind of mode, so that was right at 13 hertz. And so for 45 minutes, I was going around hanging on the end of the slinky, exciting my brain, and science really worked. I appeared to be drunk.
Wow. I was drunk just watching it.
Appeared to be. Yeah, that's right. Pay no attention to those cans in the back seat of the coaster.
All right. Well, thank you guys for your time. We appreciate it. A lot of good information, and I'm sure there will be more podcasts to come. There's a lot more information to get from you guys. So.
Absolutely. Hey, it was great. I appreciate the time to sit down with you guys.
All right. Thank you.